I'm just kidding. Good evening, everybody. My name is Oscar Salguero, and I am a Android engineer. I work for a company called Being Verified. If you guys are front-end developers or you love JavaScript and Ruby, talk to me afterwards because we want to interview you. Yeah. So the first question that you may have is, why is this Sentinel Plus? Well, 1 month ago, I came here with an introduction to Sentinel, and I spoke in a lightning talk at the previous GDG. Thank you for giving me the opportunity, and thank you to the organizers for letting me participate. This is great. I love to participate in the GDG events. I come all the time and learn a lot of new things. A lot of what you're gonna see here, I've learned at the GDG. The stuff about Firebase that I learned from Ralph in a past GDG, and Google Cloud Functions. We had all of these things before, so that's how we learn. You know, we teach each other, and that's how we grow. So this is the agenda for today. I'm gonna give a little demo. It's gonna be a combination of videos and my little friend here. We're gonna speak about the motivation. Why did I build this? I'm gonna show you the hardware, the software, and the roadmap that I have ahead. I am still, that's why this is a work in progress, because there's a roadmap and things that I still need to work on. Finally, I'm gonna give you some tips on how to get started, and tips that are gonna make your life easier when you get into this thing of building Android things, IoT devices for your home. So, little demo. Let's start with the videos. So this is the first time that I turn on Sentinel. It's a very short video, but I was really excited because this is the first time that the Bluetooth controller actually connected, and I was able to drive it. A little bit way down the road, I had Sentinel actually handing a tennis ball to my dog Duke, and he actually took it. This is the first try. I didn't train the dog to do this. I mean, so I am glad that this worked, because the whole point of creating Sentinel was to be able to take a look at my dog when I am not home. Right? I have to go to the office and I work 8+ hours sometimes. And I wanted to have a nice way to take a look at my dog and see how he was doing, entertain him a little bit, you know, pushing a ball to him or something. And he actually gets up from his bed and he goes, gets the ball. And this is Sentinel. See, he's moving around here. Oops, it moved too much. It speaks. It's just telling me the IP address that has a sign right now. I am using this Nintendo NES 30 Pro controller from 8bit2. That's the name of the company that creates the controllers. It's Bluetooth. You can use it for Android devices, for the Nintendo Switch, etc., for iOS devices. And it's just a regular Bluetooth controller. And you see that I am controlling pretty much every aspect from the Raspberry Pi with this. I'm gonna lower the volume. I'm gonna increase the volume.
Volume increased to 15.
And what if I want to go up?
Maximum volume level set. 15 is the
Yeah.
maximum volume.
Okay. Also, it's pretty handy to add speech to IoT projects, the Raspberry Pi, because you don't have a screen. So somehow you need to know what's happening. Adding speech is just a couple of lines of code, as you'll see in the presentation. And it actually helps you a lot when you are debugging. And yeah, I mean, I can drive it backwards, I can drive it to the sides, but it will fall, so I'm just gonna do forward and backward. And also I can pan and tilt the camera, as you can see here. It's looking around. Also, the controller allows me to take a picture. I'm going to take a picture of this side of the room right now, and I will show it to you later on the companion app. So yeah, going back to the presentation, what motivated me to create Sentinel? So I used to have a FOS cam, like a nanny cam, to watch my dog, right? But those cameras are expensive. You need to change them like every few years. If you want to go really, really, crazy with that, then you have to pay for a monthly service from FOSCAM to see the camera from your office or from on the go from an app. Nest has really good cameras, but the fees are kind of high. You have to pay like 100 and something bucks a year, I think. Also, you gotta have a camera on each room, which is kind of creepy, and your privacy is at risk because these cameras, the IP cameras, can be hacked. Actually, hackers have used the IP cameras to attack websites, in the past months, making DDoS attacks. So yeah, privacy is a concern. Security of the actual camera, of the security camera, is a concern. The setup is complicated. Like you have to take it out of the box, connect cables. You have to mount it in the wall, configure your router. If you are on a wide area network, on a WAN, when you are on your cell phone, you don't have Wi-Fi, you have to configure something called dynamic DNS to connect to these cameras, and it's super complicated. And sometimes you have to pay for the dynamic DNS service on a monthly basis. And a bunch of apps that I use to visualize my cameras from on the go are really unreliable. They crash. If you don't have a good connection, you see nothing. So that was part of the motivation. Also, most security cameras are dumb, right? Because they don't talk to other devices. They don't talk to you. So, they send you emails to notify you about movement or sounds. And who uses email anymore? We hate email, right? If they send you push notifications, they send you irrelevant push notifications. And there is no practical way to regulate the sensitivity of the sound detection or movement detection. So I once configured my FOSCAM to send me push notifications. It was a super complicated setup, and it sent me like a lot of nonsense, right? Like a leaf was moving out of the window, and I was getting a push notification and stuff like that. So with Sentinel, I will be able to fine-tune all of those movement detections and send me a notification that is significant. For example, if somebody opened the door, right? And I have full control on that. Also, the cameras don't have face recognition. I think Nest is working on that, but the service is also expensive. There's no image classification, so the cameras don't tell you what is on the image. And cameras can go around the house and find your pet. Sentinel soon will be able to do that. So for that, Duke, he moves from the living room to the bedroom. Sometimes he goes out to the terrace, and if I only have one camera and he's not on the frame, I can see him, right? So with Sentinel, I can go around and try to find him. Yeah, if you have a cat, they don't move much, but they kind of move sometimes. And if you have a Sentinel, then you can go and find your cat. You want to push a ball to Fido, then you can do it. Or you can scare your cat, like when they move, when Sentinel moves, your cat is going to be terrified. Also, you can check if they have food or water, because you can steer your RoboCar with the Sentinel system on it and go and take a look at the plate and stuff like that. You can keep eye on the kid. You can keep an eye on the kids. And you can see if like a package was dropped, somewhere in your house, in your porch, something like that. So it kind of made sense to make one. It has like a lot of practical uses. So now let's speak about the hardware. So this is the RoboCar platform. You can get it from Pololu, and I'm gonna share the presentation afterwards, and you can get the links to all of the parts. This is like 35, 39 volts, depending on the website. You can Google it, and they have actually some other websites where you can get it. The nice thing about the Caterpillar wheels is that they can go on grass, they can go on sand, they can go on pretty much any kind of terrain. It goes kind of slow on rocks. That's the only downside of it. This is the Raspberry Pi, right? This is the thing that allows us to push Android things to it. So yeah, I got it. I got pretty much everything that is like a motherboard from or a board from Adafruit, and I got the parts for the robot from other places like Pololu and Sparkphone Electronics. The other thing is the Raspberry Pi camera module version 2. This one is actually in use also by Antonio. And these are the motor hat and servo hat. Actually, I stand in the shoulders of giants because if it wasn't because of Antonio's RoboCar project, I wouldn't be able to build Sentinel because he laid out a lot of foundational work, especially with the power management driver via I2C for controlling the motor hat with Android things, with Java, with Android programming. So that was super important. Other stuff that I got, the pan and tilt bracket, that is the one that moves around the camera and allows me to do 180 degrees up and down and 180 degrees.
The address is 192.168.43.160.
Thank you. Yeah, that's the pan tilt bracket. I 3D printed this pedestal for the camera. I actually just went to Google and I Googled with the model of the servo that I'm using, the little servo motor. I Googled that and I Googled 3D printed camera stand or pedestal and it just showed up. And then there's a company called Shapeways that you can send a design and they'll just print it for you and they send it to you via email. So it was another 20 bucks to the tab, and it's great because now I have an elevated pan and tilt bracket. Now these expansion plates, they came from Pololu. They are transparent, but they have them in several colors. They are not so sturdy, so if I wanted to make this a little bit stronger, I would probably get some other ones, maybe made of I don't know, aluminum or something that is not so conductive because I don't want to get shocked or something. Then all of these little columns that you see on the sides, they are called standoffs, and you can get them via Amazon. I have some of them are made of brass, but I have other ones made of plastic. They are really practical because they allow you to separate the hats from the Raspberry Pi, and so you can stack them. And the power bank, or what provides the power to Sentinel, is 6 AA batteries that are rechargeable, and a 30,000 milliamps power bank, like the ones that you will use on your phone. So all in all, it was like $150, $140. Of course, that aside of that, you gotta have like a soldering iron and some rosin core and a few cables to connect everything together. Now I'm gonna tell you a little bit about the software, and it's actually Android everywhere, plus Antonio's RoboCar projects, PWM and Motorhead Java library, and you can find it at androidrobocar.com. Android Studio, an Android phone. I have a Nexus 5X that has been great for developing this. Of course, Android things. And I created a companion app. The companion app, I can actually demo for you, has been updated since I came here the last time. Now I have a way to see my motion alerts, and I have a way to manage the image history. So I'm gonna give you a little demo of the app. See. Just gonna connect to the same Wi-Fi network, and I think it's gonna work. Yes. Okay, so this is the Sentinel app, and I can drive it from here. I'm just gonna tap back. Hopefully it won't fall. Anyways, here I can receive my alerts. All of these things are saved in a Firebase database. Ooh, this is just advertisement from the Visor app because it's the free version. This is the image history. This is the picture of the audience that I just took a few minutes ago. And there you are. I can share this picture on my favorite social media app if my app is not crashing. I can control it, I can send commands. The commands go through another Firebase database table, and because Firebase is real time, it just syncs. It just syncs between the Android Things powered Raspberry Pi and the app. And here, for example, I have Antonio giving another presentation. Here is one of our attendees that took a picture of Sentinel. And it has Google Vision image classification. So when I take a picture, I use Google Vision's API to get some words associated with these images. And as you can see there, it actually recognizes my dog. It says that it's a dog, a dog breed or something, tail. There's another picture over here that it says that it's a tennis ball, this one here. So, yeah, everything is Android and Google Cloud. So it's really easy for you to go. I mean, they have like an excellent free tier that you can use to develop all of this without spending a cent. So, I mean, if you want to do it, you can do it. So yeah, as I was saying, everything that you saw is powered by Google Cloud. I have Google storage for the images, Firebase storage for the images. I have Firebase database for the database records. I have Google authentication. When I log into the application, I tell it my Google account and it logs me in. I have Firebase Cloud Messaging, that is the one that sends me the push notifications when a motion alert is detected. And I have also remote configuration that allows me to change some settings of Sentinel without having to code again those variables. I have Google Cloud Functions that create thumbnails for each one of the images that I'm taking. And this is Firebase over here. This is my Sentinel project. This is my Sentinel project over here. As you can see, I am using authentication. I have a database, and with like information about the images, all of the annotations from Google Cloud Vision are here. The alerts that I can get, either motion or sound, are here. I can have more than one Sentinel associated to my account. As you can see, this table here called robots. It has one entry for Sentinel, this Sentinel. And all of these ones that you see here, these are the actual, this is the command table that has all of the commands that Sentinel understands. And of course I have a users table with the push notification tokens that I need to send notifications. Again, this is the storage where all of the images go. And one of these images is the original image, and another one is the thumbnail. Let me see if I can find one of that is, these ones are the thumbnails, the ones that have the prefix thumb. And all of that is being, powered by Google Cloud Functions. I have a cloud function that generates the thumbnail right here. And it logs, all of the steps that it took to generate the thumbnails. Also, I have another cloud function that is to send the push notifications whenever an alert is created. And getting back to the presentation now. Now I'm going to give you some tips. Actually, I'm going to dive a little bit into the software really quickly. This is the this Atom, and this is the text editor that I use to code Firebase functions in JavaScript because it has like code coloring and it's really cool. So this is the storage function to generate a thumbnail. This is the function that sends me a push notification whenever a new record is inserted into the alerts table. So as you can see, it's not difficult, it's just JavaScript. There are a bunch of tutorials that Google has created, and I'm just like extending and modifying slightly the code labs, so it's super easy to do. And now getting a little bit into the Android code that powers Sentinel. This part that you can see here is Antonio's excellent power management driver that actually is used to drive this board over here, the motor hat, and it's the one that drives Sentinel, around the room, right? So that's the motor hat library that he created. He has a power management class. He has an Adafruit motor hat, and he has a class for each one of the DC motors, right? And then when Sentinel needs to communicate with these motors, and this is again Android's RoboCar code, you have an instance of each one of the motors, right? So here you have the motor hat, and here you have the 4 motors. And it's easy as that. I mean, you have a class that abstracts the functionality of a hardware component as a motor, and you can control it with your Android code. Now I'm going to show you a little bit of what I've done to create a driver for another board from Adafruit. This is the board that controls the pan and tilt bracket, the one that is moving right now the camera around. So that one, it is called a 16-channel servo hat, and it's the one at the top. That one can control 16 different servo motors. I am controlling only 2. There is one that moves the camera up and down, and there's one that moves the camera left and right. And again, inspired on Antonio's work, I went and created this class that abstracts the servo hat, and it has the ability to have 16 servos connected. So I could have like a missile launcher, that also pan and tilts and control when a missile is launched, or I could have additional sensors or something like that. And because I have so many places to connect all of these different sensors and other stuff, I could have arms or whatever. Actually, you could do like an arachnid, like 6-leg or 8-leg robot using another Raspberry Pi and one of these Adafruit servo hats and this library. This library will soon be published the weekend, I guess, on GitHub, and you'll be able to use it, right? So you'll only need the power management from the Android RoboCar project and these couple of classes. And then whenever you need a servo connected to one of these servo hats and your code, you just have to configure the servo, and I'm going to show you right now where that code is. It's right here. So this is the class for the servo hat. This is the tilt servo. This is the pan servo. And then when you need to use it, you just say in which pin you are connecting it. So it has 16 rows of pins. So you just give it the index. For example, the first one is connected to the index 0, and the second one is connected to the index 1. And this is how you set them up. And each servo.
Sorry, both of us are catching trains north and south, so we're going to miss the end of it. We just wanted to say.
Okay, thank you very much, Antonio. An applause for Antonio, please, because this will be important. So I'm gonna wrap up really quickly. So yeah, this is how you configure the servos. Servos can be big, can be medium, can be micro, and this library supports all of them. You just have to configure them. You can say what is the minimum angle that they take, the maximum angle they take, etc., etc. And yeah, the code is a little bit tiny, so I'm just gonna make it bigger.
We have another 45 minutes. You can take your.
Okay, thank you, Lashman. Yeah, but I won't extend that much. So yeah, so this is how you configure the servos. So it's super easy. You just have your Raspberry Pi, you stack the servo hat, and you start filling it with servos. And next, we're gonna talk about the tips about getting into this for the first time. Okay, one of the things that I did when I started this is to draw a sketch or diagram of my ideas. That helped me a lot because it helped me realize stuff that I will need or stuff that I wouldn't need. So I wrote down this list of my